Okay, I need to change some directions here. It says which of the, you don't have multiple choices here, so which, cross out, just cross out of the following. Which expression is equivalent to x to the second power plus x minus 30 divided by x plus 6? Well, you're like, how the heck do you divide that? You cannot go with this, okay? The reason why you cannot do the 3 lines is because there are plus signs within the problem, okay? So this has 3 terms, this has 2. Remember, the terms are separated by the plus sign. So you do the 3 lines if there's no addition or subtraction operators to separate the terms, okay? So here's what you're going to do. You're going to make a little table. On one side, you have to simplify these if possible, okay? So we have to put these into factored form. This is 3 terms, so this would be GCF and then the table, okay? So the GCF's 1, that's not really needed. 1 times negative 30 is negative 30, so it's a mismatch. Positive, negative. We have to add to try to get to positive 1. 30 divided by 1 is 30, that's negative 29, that's too wide. 30 divided by 2 is 15, that's negative 13, that's too wide. 30 divided by 3 is 10, that's negative 7, too wide. 30 divided by, I better find it quick because I'm running out of room. 30 divided by 4 is a decimal, and then 30 divided by 5 is 6. So 5 and 6, that's it. That's the right pairing, but 5 plus negative 6 is negative 1. We need positive 1, okay? So I can accomplish that if I go positive negative on that. Now my a is 1x to the second, okay? So negative 5, positive 6. X to the second, you go x times x. And you put the 1 there, but then those can't simplify. It's just 1x minus 5, 1x plus 6. Cross those out. Take your 1s off the front. You're like, well, now what do I do? Well, you replace this in the fraction. You replace this with this, parentheses x minus 5, parentheses x plus 6, okay? Now let's talk about x plus 6. Now that's 2 terms, okay? So GCF and DOPS. Problem is the GCF is 1, so nope. And then if I look at that, I have a plus sign, so it can't be a DOPS, so this is a prime expression. So if it's prime, all you do is keep it as x plus 6 with a parentheses. Now what happens is this and this go away, and we just have x minus 5, okay? Next problem, which of the following expression, cross out of the following, and switch your expression, the S, to just a singular. Okay, I got to delete that on the thing, so it makes more sense. Okay. X to the second plus 8x plus 15 divided by x plus 3. Again, this has 3 terms, this has 2 terms, so you're going to need to factor it rather than go to the 3 lines, because when there's plus and minus, that means that's polynomials. That's a trinomial, that's a binomial, okay? So you have x to the second plus 8x plus 15, and then we have the binomial x plus 3. So let's do our hard one first, the trinomial. So GCF, and then the table. GCF's 1, so ABC, the AC product, 1 times 15 is 15. It's positive 15, okay? Positive 15. So that's got to be a match of the signs. So you can put in double negative or double positive, but they have to be the same thing. It's got to be positive 8. 1 and 15, that's negative 16. No. 15 divided by 2 is a decimal. 15 divided by 3 is 5, and that's right, we just got to make them positive 8, so they go to double positive, so that they can actually add to positive 8. Positive 3, positive 5. A is 1x a second. So I got positive 3, positive 5, and I know the x seconds, x, and then we got 1. Now I really don't think you would divide those only by 1, which would just keep them the same. Then you take the 1s off the front, okay? And what you're doing is replacing this trinomial with the 2 parentheses, because it's like, you know how when I say FOIL, you do the distribution? Well, now I'm like undistributing it, okay? So, x plus 3, x plus 5. Now, x plus 3, that's 2 terms, so that would be GCF and DOPS. GCF's 1, and there's no way that's a DOPS because of the plus sign. So that's a prime expression. So we just keep that as x plus 3. You'd put a parentheses, these go away, and you would end up with just x plus 5. That's the quotient.